Algebra 2 students, in this video today, we're going to be learning another way to solve linear systems. And of course, you're like, great, another way to solve linear systems, but it's a pretty fast way. And sorry for yawning, and to be honest with you, it's important. I mean, it's Cramer's rule, which is something you'll need to know in the future, and it is a fast way to solve linear systems. So in this video, that's what we're going to be studying. Your heading for today is called Cramer's Rule. The lesson number is 4.7, and be sure and include today's date so that your notes are good and organized. Okay? Cramer's Rule, lesson 4.7, and be sure and include today's date. Alright, here we go. Now, Cramer's Rule, just so you know, is much easier than using augmented matrices, which is what we just studied in lesson 4.6. It's much easier, okay? So relax and understand that. It's actually a pretty simple concept once you get a hold of it. CR, Cramer's Rule, CR uses the determinant of a matrix to solve a system. That's what we're going to use, is determinants, okay? Now, like I've told you before, some math problems require steps and others do not, okay? So with that in mind, we're not going to be using steps for these problems, but just step-by-step examples as to what to do, okay? And I think you'll find that definitely easy enough, okay? So here's our first problem. I want you to solve this system using Cramer's Rule, okay? So watch carefully as I do this. Solve this linear system using Cramer's Rule. Are you ready? Take some good side notes off to the side. Here we go. You have to decide first of all whether you want to solve for x or y. Now sometimes in your homework I tell you what to solve for first. Sometimes I don't. So you can choose. In this problem here I'm going to tell you we're going to solve for x first. So here we go. You write x equals and then put a big fraction bar. Everyone can do that. That's pretty simple, okay? X equals and put a big fraction bar. Now the reason we did that is we're going to put a matrix up top and we're going to put a matrix in the bottom, okay? Got that? That's so easy. Now, you always take the coefficients right here and put them in the denominator. Always, 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 always. So here we go. 4, 3, -2, -5. That will never change. Do you understand, students? You might want to write that down. That will never change. Now this is my x column. This is my y column, correct? X coefficients, y coefficients, okay? Now, next, here's what you do. You say to yourself, what am I solving for? Well, I'm solving for x. So since you're solving for x, you're going to come up here, you're going to drop out the x column. Now if I was solving for y, if this was a y over here, then I would come up here and drop out the y column. Do you understand what I'm saying? But I'm solving for x, so since I'm solving for x, I'm going to drop out the x column. I'm going to pick up these two numbers here and put them in place of those two numbers, 4 and 3. So there's your new matrix. 10, 11, -2, -5. Let's go over that one more time. I'm solving for x. Now your denominator never changes. In a second here we're going to solve for y, okay? Guess what? Your denominator stays the same. It will never change for this problem. But the numerator will change, okay? We're solving for x, correct? So come up here and cross off your x column, and in place of it put these numbers right here. So my new matrix up here is 10, 11, -2, -5. And now you know what you are. You are basically home free. You're going to find the determinant of this, the determinant of this, and you're basically done. It's a really fast way to solve for linear systems. So here we go. Multiply up -22. I'm going to put a positive 22. Multiply down -50. So the determinant would be -28. Pretty simple. Multiply up -6. So I'm going to put a positive 6. Multiply down -20. Combine those, you get a -14. So x equals -28 over -14. Well, negative over negative is positive. 28 divided by 14 is 2. Boom, just like that, we have our x value. Not sure why I put an x there, but that's okay. Now, all I have to do is find my y value, okay? Now, Mr. Earhart, you're making this more difficult than it is. Could we not just pick up our x value and substitute it in for x right here? Most definitely. And on most of your problems on a test or quiz, I'm okay with that. But since you're taking notes today, let's practice solving for y, also using Cramer's rule, okay? Now, notice I left this up here for a reason. You'll see why in a second. Okay, let's solve for y. Now remember what I taught you. The denominator never changes, right? So my denominator would be these numbers right here. 4, 3, -2, -5. You know what, students? Why did I even write that? Because I already used this matrix in my x. Look at your notes and you'll see. Look at your notes. When we solved for x, this was our denominator. Didn't we find the determinant of this already? What did we get? So there was no need to even write that matrix. Do you see what I'm saying? Just put what right here? -14, because you already know what matrix goes here. And you already found the determinant of it. It's -14. So once you found one variable, it kind of cuts the rest of the variables in half. The time. It cuts the time in half. Now for your y, watch carefully. Here's where I don't want you to get confused. We're solving for y, correct? So you drop out your y values, and right here you put a 10 and an 11, okay? So your matrix is going to be 4, 3, not negative, sorry. 4, 3, 10, 11. What about these negative signs here, Mr. Earhart? Well, because you're solving for y, you're dropping out the entire y column. That means all of these numbers. And you're putting in place of those numbers 10 and 11. So 4, 3, 10, 11. And now, here we go. We can solve for y so quickly. Alright, here we go. Multiply up 30, so I put a -30. Multiply down, +44. Combine those and you get +14. Your denominator's -14. So +14 over -14 is -1. And that's what y equals. Y equals -1. And we're finished, guys. Okay? Now, like I said, relax. On a test or a quiz, I will definitely let you use Cramer's rule. I will only make you use Cramer's rule on one variable, and then you can substitute it in and find the other variable, okay? But I want to practice this, alright? Now, let's try another one. Now, on this one, I want you to solve for y first, and then once you find y, substitute it back in and solve for x. So we are not going to use Cramer's rule twice on this. On this problem here, we use Cramer's rule twice. Once for x and once for y. But here, we're only going to use Cramer's rule once, and we're going to use it on y. So are you ready? Here we go. Y equals, if you want to work ahead, that's fine. Y equals, my coefficient matrix right there is 8, 2, 5, -4. Okay? Now, notice you're solving for y. So you come up here and you cross off the y column, and in place you put these two numbers, 2 and -10. So up top here I'm going to put 8, 2, 2, -10. Order is very important. You cannot put this column first. The order is very important, okay? Alright, let's multiply up. That would be 4, so I'm going to put a -4. Let's multiply down. That's a -80. Combine those and we get a -84. Multiply up, I get 10, so I'll put a -10. Multiply down, I get -32. Combine those two and I get a -42. So negative over a negative is positive. 84 divided by 42 is 2. Okay, so I have found my y value. Now to find my x value, simply substitute that back in for y. So 2x -4 parentheses 2. And by the way, remember students, when you are substituting 2 in for y, you can do it in this equation or this equation. It doesn't matter which one, okay? So here we go. Negative 4 times 2, that's a negative 8, equals a negative 10. Bring the negative 8 over and make it a positive 8. And so we have 2x equals negative 2. Divide both sides by 2, and x equals negative 1. A negative divided by a positive is negative 2 divided by 2 is 1. So there is your answer. Alright? Negative 1, 2. Now, I hope that makes sense, guys. Okay? This is a very short teaching video. I'm making it short on purpose. There's just not a lot of work to do. It's a pretty simple procedure, more than taking notes. You need to practice. However, I want to throw one more at you. It's a little more difficult, okay? We can also use Cramer's rule on a 3-variable system. So, I'm going to tell you now in your notes we're going to use Cramer's rule to solve for x. Then we're going to use Cramer's rule to solve for z. Then once we know x and z, we'll go back and substitute it in and find y, okay? So let's start off solving for x. Are you ready? You should know what to do. We're going to have a big old 3 by 3. All of your coefficients right here, okay? So negative 1, 2, 3, 2, 0, negative 4, negative 3, 1, positive 4, okay? Now, we're solving for x, correct? Sure we are. So we're going to drop out our x column, and in place of it, put these numbers over here. 1, 0, 2. So my matrix up top will be 1, 0, 2, and then your y's, 2, 0, negative 4, and then your z's, negative 3, 1, 4. And now we're all set, students. Let's find our determinant. Remember, do you remember how to find the determinant of a 3 by 3? You have to copy the first 2 rows over again. Or the first 2 columns, excuse me. I said rows. Copy the first 2 columns over again. Okay? So negative 1, 2, 3, 2, 0, negative 4. And here we go. Let's see what happens. Now here's the good news. Remember, this matrix here will not change. So, when we go to solve for z next, we would not have to do all of this work again right here, okay? Alright, here we go. Multiply up, I get a 0. Multiply up, negative 4, so I'll put a positive 4. Multiply up, 0. Multiply down, 0. Multiply down, positive 4. Multiply down, 0. Positive 4 is 8. Now let's find the determinant of the denominator. Multiply up, you get a 0. Multiply up, positive 4, so I'll put a negative 4. Multiply up, you get 16, so I'll put a negative 16. Multiply down, you get a 0. Multiply down, positive 6. Multiply down, positive 24, I believe. Yes, 24. So let's see, we have 30, negative 20. Let's see here. 30, negative 20 would be 10, yes. Positive 10. So 8 over 10 reduced would be 4/5. So your x value is 4/5. And that is correct, by the way. That is the correct answer for x, 4/5. Now, look at your denominator. Is everybody looking at it? Look at your denominator. What is it? 10. Come over here and write that down if you need to. Denominator equals 10. Because in a second we're going to solve for z. And guess what? Your denominator doesn't change. So why in the world would you want to write this matrix right here again? And then copy the 2 columns over again. Then do all of this and all of this to come up with this. You already know your denominator is going to be 10. So please don't forget that, okay? Alright, next, I want us to solve for z, okay? So z equals, now for your denominator, put a 10. For your numerator up here, we're solving for what variable? Z. So cross off your z's. And right in place there, you're going to put a 1. and a 0, and a 2. So for your x column, it's negative 1, 2, 3. For your y column, 2, 0, negative 4. Now, I'm putting a 0 here, not because there's a 0 here, because there's no y term right here. Okay? And then 1, 0, 2. 1, 0, 2. So now, copy your first two columns over, find the determinant, and we're just about done. And here we go. Multiply up, you get a 0. Multiply up, you get a 0. Multiply up, and you get 8, positive 8. So I should put a negative 8, shouldn't I? Negative 8. Multiply down, we get a 0. Multiply down, we get a 0. Multiply down, and we get a negative 8. So I'll put a negative 8. So my negative 8 and negative 8, my determinant is negative 16 for my numerator. My denominator is 10. So if I reduce that, I get a negative 8 fifths. Let me check the book and make sure that's right. Yes, that is correct. Now, we're pretty much ready to solve for y. Alright, so I'm going to take my bottom equation here. 3 times 4 fifths, negative 4y, positive 4, and then c, negative 8 fifths, equals 2. Now simplify first. If you're like me, I cannot wait to get rid of my fractions, but never, ever get rid of your fractions first. Always simplify first. So 3 times 4 fifths is 12 fifths. Negative 4y is negative 4y. 4 times negative 8 fifths is negative 32 over 5. Equals 2. Now your denominator is 5 and 5. So we're going to multiply the entire equation by 5. Now what if it had been 5 and 15? Well, what's a common denominator for 5 and 15? 15 is, so you would multiply the entire fraction by 15. What if you would have had a 2 right here? A 2. Well, then what's a common denominator for 5 and 2? 10. So you'd multiply the entire equation by 10. Alright, okay. So my denominators are 5 and 5. Let's multiply everything by 5 real quick. 5 times 12 fifths, or 5 times 12 fifths would be 12. 5 times negative 4, negative 20. 5 times 32 over 5, negative 32. Don't forget your 2. 5 times 2 is 10. There we go. Combine your like terms, positive 12, negative 32. That would be a negative 20. And then bring your 20 over and make it a positive 20, and you're left with negative 20y equals 30. And now divide both sides by negative 20. So a positive 30 divided by a negative 20 is negative 30 over 20. Of course, reduce that, and you get negative 3 halves. Negative 3 halves. You can divide the top and the bottom of this fraction by 10. Negative 3 halves. And that is the correct answer. Okay, guys? So Cramer's rule will work on all of these different sizes of variable systems, as long as you know how to find the determinant of the different matrices. Okay? I hope this video has been a help to you. I hope you understand what I've said. If you have any questions, don't hesitate to call or email.